Considering only one case, because our seismic load will have a reaction sa ating base shear na going this direction, tapos may reverse na going to the another direction. So for this load combination, we'll only consider one case. Okay, so let's review ilang dead load na natin na uniform.
Bukad.
Dead load, na ito
Boss.
7.973 kilonewton or meter.
Dead load na sir? Hindi 17 to?
Ha? Ang uniform, dead load.
May moment ng load.
973. Iliwat na, ang muling needed ninyo to represent your load diagram, okay, for your trainings. Okay, so you can solve your seismic load without your dead load. Okay, and we now have our total uniform load, okay, acting at each floor. Okay, and in order for us to solve for our seismic load, okay, we need the load diagram for our dead load. Okay, proceed ta sa seismic. So let's solve for our design base shear, review lang. So we need first our seismic design coefficient. Okay, ang C natin. Okay, so that is CDI over RP. Okay, so given natin anong mga coefficients. Okay, so we have an A and B katay. So we need to solve for our CB. CB, CA, ano ba ito? Ang R? Ang R, iba no? Wala. Ang R.
Sorry lang sir.
Ano natin sa P? Ano natin CB ah?
Sir, profile na
So for our CB, wala kundi sa NCQ.
SD. Basta yung may given niya. $160. $160 na.
Okay, so since this is seismic zone 4, seismic zone 4, I mean. Okay, so let's solve for CA. So near source factor ta, given as a problem. Okay, so we have a near source factor of 1. Okay, both for an A and B. And for our CA at CB, may distance na wala. Ay, natin ang near source. So for our CA, wala kami hatag na wala kami hatag na soil profile type, so we'll use SD. Okay, so CB for zone 4, that is 0.44 and A. Okay, for our CA, sulit.
Dinarisi na talaga kay Elvin.
Then for our CB, this is 0.64. Then this is an SMRF frame, so R is equal to 8.5. And last, let's solve for your structure period. Here.
CTHN 3 part.
CT, HN, raised to D over 4.
3, 1.
Bilang ato ng HN. Okay, unlike ito gawin load, sa ato niya HN is measured from our base. And ang base na consider natin is from the top of footing. Okay, so let's consider our transverse frame. Aliwat, sa wind load yan, dali siya din measure halin from your ground floor level. Okay, dili man kasugod ato wind load. But for our HN, dito sa ating na top of footing. Okay, so that is 3.5 times 3
12.5.
plus ang ato na 2. Ilan natin HM? 9, 10.5, 12.5. Then for our safety, okay, so this is moment of safety.
0.731.
0.0731. So we can now solve for our static. 0.0731 plus 12.5.
Oo.
Okay lang kita.
0.486.
0.486.
6. Round up na na sir.
So let's solve for our design seismic coefficient. CV is 0.64. Ang I is, hindi na I know, this is 1. Ang R is 8.5. Ang ato na P is 0.486. Okay lang isa? Yes,
0.1549.
1549.
49.
Okay, let's check your CMAX exceeding. So for CMAX, not be less than
2.5. Mean niya sir? Si max around 2.5.
2.5
CAI over R.
I over
CA 2.5. Oh? Ito yan?
lang CMAX.
12.94.
Okay. And this is less than sa atong na C nga 0.1549.
Therefore, use the
Therefore, use C equal to 0.12. Okay, review lang. So we now have our design seismic coefficient. Ang question, sir, paano magsuma sa aton na seismic net load? Okay, kung hindi given ang aton na mga seismic net load. So, previously, we have solved for our total uniform load acting, no? So, including na din aton na self-weight, nadala ding weights ang slab, nadala ding weights ang beam. Okay, but we won't include ang weights ang column, kaya insignificant ang iyang total weight compared sa linateries ang aton na beam sa slab. Oh. Paano ka isolve ang aton na total seismic net load acting on each floor? Okay, so let's convert this into a single, no, concentrated load acting at each floor level. Okay, question, pila total width sa aton na building? Okay, so here, from our framing plan, so this is a longitudinal frame, ha? So along this long direction ng framing natin. So let's consider on-center spacing lang. Okay, but we know, no, ang aton na loads is hasta sa edge sa aton na girder. But for this computation, we'll consider only on-center. So ang total length, ha? Yan, 8.5 times 2 plus 7.2 lang. Yes, correct pala to?
24.5.
This is 24 point.
Ay, 24.2. 7.2 lang.
2.
24.2.
8.
7.5.
24.2 times 17.973. Pila?
Ha? Ganyan ito, nabigyan ito.
Ilan? Total seismic net load acting at pila?
434.9466.
434.9466.
9466.
Since ang atong net load same lang all throughout sa atong roof deck, third floor, second floor. Okay, so ang aton na seismic net load is the same din. But there are instances na atong net load is na-ibay. So let's say, di man may roof deck mo, ang inyo ding ang finishes is different from your lower floor levels. Usually, kung roof deck, kinanglan may waterproofing ka mo. Okay? Mga usual mga waterproofing is either magamit ng isang torch membrane, kaya lang sa ano, pinarolyo siya, tapos pinaspread siya sa roof. Tapos ina-torch siya. So may harap ngayon sa mga emulsified na mga asphalt na ginagamit for waterproofing. Ang usual na mga standard, if this is your roof deck slab, okay, so we must protect our roof deck from leakage against sa rain loads natin. Kasi syempre pakulan, unlike sa roofing natin niya, ang aton na roof deck is may possibility magpanding din aton na tubig sa ulan. Okay, kasi na nag-provide pa enough na drainage dahil kasi may enough siya na slope, okay, ang inyong makadahulog sa ulan, hindi mo siya ma-prevent. Okay, eventually mag-drain out siya, pero pwede kasi magpanding ang inyong ulan. So inobra, ang inyong roof deck, they are poured monolithically. So dapat wala kang sa construction joint all throughout sa inyong roof deck. Amo na ka mag-topping off sa mga construction sites sa ilang roof deck, wala ginautod. Di ba usually ilang inobra, zoning sila, zone 1, zone 2, zone 3. But for roof deck, ginahulat ng other zones na magsaka before mag-topping. Kita may breath dire, if ever this is your roof deck na maintain, ang usual ilang inobra is mahimok sa construction joint. Para makatipid sa materials na ma-rolling nila from other zones. So if ever magbutang ka sa imong construction joint, tapos nabuhos ka ng risapyak dali. Okay? Ang initial construction joint may be a cause sa inyong leak sa inyong roof deck. Kaya kinanglan siya wala sa construction joint. So aside dira maging monolithic mo pour ang bilog na roof deck, kay ma-add pa kita sa aton nga waterproofing. So usually if this is your roof deck, okay, niyara ka mo parapet wall. Siyempre dapat may parapet wall inyong roof deck alangan open ang inyong roof deck mo. Okay, parapet wall ka. Ako sila kayong taas ni nga wall basta mga baro mo gawin gamit sa wall pa rin beam.
1 meter nga beam, sir?
1 meter nga beam. Okay, then ang inyong roof deck nabutangan sa waterproofing. So it could be, butong mention ko, na torch membrane. So may aras ng so sheet. Explain ko ano na siya mga waterproofing. May aring sa MCT. Luminous membrane. Ano siya? Yan. Waterproofing membrane. So tanang roof deck may waterproofing na. So pwede siya bituminous, either gravel cover or smooth surface. Ang usual siya bituminous, sir, bituminous waterproofing naton. Ang usual nyo makita sa dalan, ang ginaluto pala, asphalto, tapos kinabutangan aggregate. Then ang iba naman yan, nasa liquid apply, this is the emulsified type. Kaya nga that is, ang iya yung solvent is water. Then last, niya kama sa torch applied. Ang mga single ply sheet na bala, nakagulyo na siya, tapos spread siya all throughout, tapos i-torch nila para matapik sa inyo na roof decks lang. Okay, so for short, alam na roof deck may waterproofing. So let's say yung waterproofing nakamudik, naka-apply na kang waterproofing. Anong nakasulat nila? Per layer, no? Hindi. Wala siya nang sulat mo per thickness. Then after sa inyong waterproofing, syempre low ay man, itang inyong roof deck, ano siya, asphalt. After that, inabutangan siya sa inyong concrete topping.
Dupit sa
Okay, this is your waterproofing. Tapos, nyakat mo sa concrete topping. Sir, paano magsuma sa dead load for concrete topping? Usually, concrete topping is around up to 50 mm. Kaya yung total yung thickness is 50
thickness ng sinto.
So discover nyo bilang thickness na ginagamit for asphalt. Kaya din naman sir paon ang dead load for concrete topping. Ano din, may floor fill ka mo. Okay? So pwede ka ma-floor fill na stone concrete per mm. Okay, after sa inyong waterproofing, may akam sa concrete topping for roof deck. I-emphasize ko lang na siya, kaya hindi niya siya maging same ang inyong total dead load sa roof deck compared sa inyong lower floors. So, inyong lower floors, na inyong floor finishes, tiles, okay, and if ever yung mga ceiling, same na rin. May natabuan na rin na same sila. Okay, na 17.973. So, but for your roof deck, you must consider your waterproofing. Okay. Try me observe ang sa may Ayala.
Sa'yo mo na gali. Sa'yo mo na sa unit weight. Yung multiply mo.
Okay. So let's solve for seismic dead load. So our seismic load acting on our critical frame, okay? Sa atong nga longitudinal frame. Okay, so we must sum up kanang na seismic load acting at each floor level. So this is 434.9466. This is 434.9466. Sir, question. Ang seismic load sa transverse frame, same din din. Walain natin siyempre lain ang inyong span for your transverse frame. So total seismic load 17.973 times 3 pila eh? Yes, pila to?
9.7
30.
53.919. 53.919.
53.919. Then we can solve for our seismic base shear. So 0.1294 times 3.919. Pinaka total seismic base shear. Okay, kailan to?
6.97775.
977.
Hindi, 6.9. 6.97775.
6.977.
Ay, wait.
9.771.
3.12. Tapos, sorry? 12% of 50.
Amo to ang example sa inyong pagsundron liwan.
Ah,
434.9466 times 3. May ang total seismic load O, pila na eh. Ipakita ko lang inyo ang common error. So, dapat amo siya ng pagsundron. So, dapat amo ni siya.
1304.8398.
1304.8398.
98. Times 0.12.
Pilang total seismic base shear?
168.862.
168.863.
862. 3 na lang, sir.
Sige na lang.
Pero dako man.
Dilitan. So we now have your total seismic base shear. Okay, acting at your longitudinal frame. Okay, and we need to distribute any nga base shear acting at each floor level. And this horizontal force
Yun siya,
acting at
ibibigay na.
each story or at each floor. Okay, this is
861.
called as your story
Yeah.
shear.
Yun na lang.
Basta this is your story shear. Okay, this is a total horizontal force acting at each floor, okay, due to your base shear. Okay, may story shear ako. And how can we solve for our story shear? So from the code, okay, we can distribute our total horizontal forces at each floor as defined as section 8.5.2.3. But we will consider sa roof deck nato ng FR nato. Yes.
8463.
Ha?
84.
168.8463.
8463.
8463. Sure yan eh. Promise. Okay. Malutang, ang total story shear na acting at our roof level is composed of our horizontal distribution plus isang aton na FT or your whiplash force. Okay, di ba ta? For our FR, okay, ang total din na horizontal force is composed, okay, isang aton na force acting at our roof deck level plus isang aton na whiplash force. Okay, so how can we solve for our whiplash force F sub T? Isang whiplash.
Sin nila, diba, sir?
Diba kung mag-sway siya, may aras ng effect na
Sino na,
mag-sway
diba?
siya. Okay, mas slender ang inyong mga building, diba mas lawig siya mag-sway. Kung dasig siya, diba, ang inyong mga base sa building, if mag-move siya sideways, okay, kung tamaan siya ka-slender, ang inyong topmost is kapabilin. O tapos pagbutong niya din, ma-whiplash siya pabalik. Okay, kung mas nabuang inyong mga building, okay, pag-move niya din, diba makakabilin siya. Pag balik niya, ipot na, wala sang whiplash effect. Ang nag-mention niya, if ever ang inyo total structure period
Kung 0.7
If total structure period is 0.7 seconds or less, wala sang whiplash effect. Okay? Ang significance ng aton na structure period is ang main total period na mag-sway ang building from one side, na makomplete sa complete sway, okay, from one side going to another side, then mabalik sa iya nga original position. So kung mas lawig siya, okay, and sige vibrate ang inyong building, may kakasang whiplash effect. I-have-view nito kaya. This is the whiplash effect. So kung mas nubong building, idasig ang iya response, wala sang whiplash. Sa mga model, whiteboard marker.
Structure.
Sa may CIP, niya sila sa earthquake simulator.
Structural modeling na. Structural modeling na.
Structural modeling na. So since aton structure period is 0.486, okay, so that is less than 0.7 seconds.
Therefore,
So 0 ang aton na whiplash force. Okay, since structure period is less than 0.7 seconds. Okay, so let's proceed sa aton na horizontal distribution. Okay, paano suma sa FR, F3, CAD, F2. So si code ng BAL, we can solve for our horizontal distribution as the following equation. Okay, using the following equation. So Fx
V na.
Okay, so at any floor level, okay, that is equal to our base shear minus Ft multiplied by the total seismic dead load, okay, acting at that floor level multiplied by its height measured from our base, okay, link base na at that floor level also, divided by the sum, okay, of the product of each seismic dead load sa each floor ng iya na height ng our base. Okay? So that is from I equals to 1 going to N. So let's solve this. Summation of WI. Okay? So in case multi-story ang ato na building, may tudlo ko nga ninjutsu.
Oh yeah.
Okay, this is the sum of the product ng inyong seismic dead load sa iya nga height from your base level. Okay, we go to mode 3. Okay, mode 3 ito. Wala ko din sa palpit. Okay, so may two tables na mo dira. You have your column X and column Y. So for column X, we will input here the values ng aton na seismic dead load acting at each floor level. Ng inyong Y, inputin natin ang iya nga height from our reference base. Okay, so we have pinaka levels. Okay, 3 levels, no? 1, 2, and 3. So this is for level 2, this is for level 3, and for level 4. Sorry nga, wala level 1. May atong ground floor is not connected sa atong na mainframe system. Kaya ang atong na slab on grade, atong na slab on ground floor is slab on grade na design. Okay, so for our second floor level, ilang atong na total system load? That is 434.9466. Same on the way, 434.9466. Okay. Then, ang atong nga Y is the height ng each floor level na doon, measured from the base na doon. Okay, so for our second floor level, okay, refer to the training plan sa may mga heights. Pila? That is 2 plus 3.5. Pila nito?
5.5.
Ganta ka mo tipan. Sa inyo nga mode 3 2, pwede ka maka-insert equation. 2 plus 3.5, siya na masuma rin. 2 plus 3.5 is 5.5 meter. Since may 5.5 ka na, 5.5 plus 3.5. Ilan siya? 9. Automatic na isuma ni each cell sa inyong motion ito. Then 9 plus 3.5, this is 12.5. Press Shift AC. AC lang AC. Okay. So for Canon, may option. For Canon, percussion, sa Canon naman may apps. Din makitaan ang mga sum sa Canon.
4.
Apps 4. Then ang XY, sum XY. 5. Okay. Dapat ang magawa nila is sum XY. Okay, percussion. This is mode. Shift stat. Shift stat. Din ang sum makitaan. 3 ang summation of XY. 5 man same. So dapat yung magawa nga summation of XY. Okay. I-introduce ko niya in case na multi-story, let's say 10 di ka story ang inyong mag-inasama. Okay? Pilang aton na value dito?
11743.
Ilan?
11743.
11743.
0.5582.
5582. Question, paano yun? This is kilonewton
Meter.
Okay. So we now have the sum of our product sum, seismic dead load acting at each floor level multiplied by its height from our reference base. Okay, next. Okay, so let's solve or let's distribute our base shear. Okay, so for our second floor level, F2, okay, that is equal to ang V natin or total base shear. So 168.8463. Okay, then ang iya kasi seismic dead load, okay, at your second floor is 434 Jacob. 0.9466. Height na is 5.5. All over 117.43.558. Ilan eh? Ilan doon?
34.
Ilan? 34. 39.
46.
Okay, for our third level, same na naman si seismic dead load at that floor. This is 434.9466. Okay, ang height niya is 9 meter. Ilan eh?
56.2821.
56.2821 kilonewton. Then last for our third level, 434.9466.
1696.
Ilan eh?
78.1696. 696.
Okay. Pasyon, pagyatag na total horizontal force acting at our roof level is equal to our F4 plus some whiplash force. So this is 78.1696 plus ang aton na whiplash force na 0. So therefore, total force at your roof level is 78.1696 kilonewton. Okay, sa liwat ang ilis lang nga force, this is a total story shear due to earthquake acting at your second floor. Okay, total story shear due to earthquake acting at your third floor and total story shear due to earthquake acting at your roof deck. Okay, these are all story shears. Okay, then after this, okay, we need to analyze our framing. Sa liwat, ang atong objective for this problem is we need to determine the required moment at face of column E. Okay, for beam EF. Okay, this is beam EF. So let's use portal method. Diba for portal method, ang assumption ang mid-height ng column as long nga fixed ended ang aton nga column going to our footing. Okay, the mid-height is assumed as pin and the mid-length ng aton nga girders and beams are assumed as pin. Okay, then ang aton nga equivalent horizontal forces acting at the mid-height of your column is twice ang effect sa aton nga horizontal reaction at your interior columns. Then for your exterior columns is single lang horizontal reaction. Ang reason behind that is for each portal frame may equivalent ka mga duwa nga horizontal shear. Okay, kaya ang inyong story level will resist a story shear. Okay, so for your interior columns, kung combine na duwa ka portal frame, duwa ka effect sa inyong horizontal shear. Review na lang. Portal. Kita. So total height ng pilar. Atong floor to floor ano what?
3.5.
This is 3.5 over 2. Or this is 1.75. Then ang length sinin. Ilang length na on center lang ay
8.5.
Ganun po sila ng mga figures. 8.5. This is 4.25. Okay. Liwata, ang atong objective is to get the moment acting sa atong na beam EF at the face of column E. Okay, kaya previously we have acquired long values ng moment at due to dead at face of column E. Moment due to live load T1 at face of column E. Moment due to wind load T1 at face of column E. And last, okay, we now have our seismic dead load, seismic load, phase 1, okay, acting at your column E. Ang iyang moment. Okay, anong kinahanglan natin na reaction din? Wait lang. So, matada na isang P. O, tama, excited. So, ito na.
Radyo nila. Ayan mo. Radyo nila.
Okay, so let's consider this as FBD1. Okay, and this is FBD. Okay, refer to FBD1. Okay, sorry, 2. Summation of forces horizontal equal to 0, assuming all going to the right is positive. So this is 78.1696 minus, that is 60, no? 60 is equal to 0. Ilang beta?
13.0283.
0,
283.
283. Ilang newton? Yes, question. Dahita, this is framing ng EFGH. Okay, longitudinal frame.
Height niya 3.5.
Height na yung...
Ano siya? Top view ni top view. Top view. Okay, ang section view ta. Okay, this is your longitudinal frame. Okay, we are solving for roof deck level. Okay. Ang ato nga AX is equal sa ato nga B. So, refer sa FPD1. Okay, sumahon ta. Anong kinakailangan natin para masumat ang moment about phase E? Okay, we
BY.
power BY. So, let's sum all moments about point A or the L. Tinta. Ha? Kaya sa A, no? Para makuha si BY. Sum all moments at A.
Horizontal, sir, para sa BX.
Si BX.
Strong summation of forces horizontal is equal to 0. A going to the right is positive. So that is 78.1696. Less ang ating EX, that is your B, 13.0283.
Minus X.
Minus ang ating na BX is also 0. Ilang BX na?
6.5.
16, 65.1413.
141.
3.
3. Okay, next. Summation of moment about point A. Okay, so this is negative 78.1696. Moment R is 1.75. Then si BY is 4.25 BY. Then
Plus
plus EX is
65.
1.75 65.14. Kailangan natin na BY.
Yeah.
Tsaka consumption ta. Tama ba?
5.3645.
5.36
46.
46. Okay, may BY ta. Sa liwat ang ato namin nakuha nga moment is the moment at the face of column A. Okay, ang inyong measurements, they are measured from the center sa inyong column. Okay, kaya ang assumption earlier, no, sa itong dead load to glide load, all moments are measured from the face of your columns. So drawing ta, considering the width sa column.
Radyo.
I-reiterate ko ang ato ng moment when kuha from our dead load, live load, na wind load, they are at the face ng ato ng column. Okay, so dapat ang ganito sa moment arm is not being 4.25 but we will consider the width ng column na. Okay, so this is 4.25. Pilang size ng column gani?
0.45.
415 no, or is 0.45 over. Ilan siya?
3.8.
3 point.
Hindi, wait lang sir. Wait lang. Sa lagali. My
Wait,
falls.
dali, okay, ito, 3 point.
0.225.
My falls.
0.225. Ay, di minus ka, sir?
4.0225.
025.
4.025.
025 lang sir.
025. Ina na. Okay. So we can now solve for our moment at E due to seismic dead load. Due to seismic load. A moment at E due to earthquake load. So a moment at face of column E, okay, due to earthquake. Okay. Ano assumption ta? Clockwise or counterclockwise? Ano siya? Ano siya no? Dapat mo niya. That is a positive movement.
Clockwise.
Iyari natin ng movement at E. So this is equal to 5.3646 times 4.025. So bilang ato ng movement at E due to earthquake load. Okay, positive siya.
21.5925.
21.5925
5925.
kilonewton. Okay? O, tapos ito sa atong na structural analysis. Okay, after sa inyong structural analysis, considering you have already solved for all load cases. Wow. Pila to ka load cases lang eh. O, summarize ta. So, moment at E due to that load, kato gani, this is negative. Yes.
72.7935.
79.35 kilonewton. Next. Moment at E due to live load. Negative.
38.
Sila?
38.3554.
3552.
4. 3554.
3554 kilonewton meter. Next.
With you.
Moment at E due to wind load. Phase 1. Negative or positive?
Hindi na yun?
Positive. 37 point. Strong. 27 point. Bansit. 27 point. 7733. Then for our seismic load phase 1, that is positive 21.5925 kilonewton. Okay. So may mga end moments at the face of your column A for your beam EF for each load cases. Okay, take note ang atong na live load, we have already or we are only considering live load phase 1. Wherein ang atong na loadings are 100%. Then for our wind load, see, we are only considering one case man. Okay? O, ano ito natin yung load case dali? For earthquake natin, for wind load natin. But this is blowing perpendicular to ridge.
Positive GCPI.
Tapos,
Positive
nagamit isang CP2.
CP2. Positive GCPI.
Tapos, positive na GCPI. Then for our earthquake, okay, na-consider only one case. Okay. Ang atong assumption sa earthquake is going to the right. Okay. Ang atong na case 2 is the reverse effects ng atong na earthquake. Anong target ka dili? Okay, sa liwatan, di ba from our principles of reinforced concrete, if this is a reinforced concrete frame, syempre ang subject is CERCDN. So dapat ang atong na target, di ba, para ma-design natin is our design strength, this should be greater than or equal sa atong na required strength. Okay? This is your design strength, this is your required strength. And as per section 404, section 405. Okay, so for our required strength U, So we will consider the following load combinations. So we have pilang equations, 1, 2, 3, 4, 5, 6, 7. Okay, okay 7 equation. And ang ating load combi is our required strength. Okay, pila kabilog ang ating internal reaction gani. First, we have our moment. Okay, this should be greater than or equal sa ating na required strength for moment capacity. Second, for our shear, PB, and this should be greater than or equal sa ating BU. Okay, PPN portion natin, this should be greater than or equal to TU. And last, for our action load, PPN, this should be greater than or equal to TU. Okay, and for this problem, ang i-consider natin is only our moment. A moment at one location lang. Okay, na-point out ko na hindi lang isa kabilog ang inyong i-load combi. Okay, tanan na internal reactions sa inyong abin, shear, moment, tag, action. And let's focus na for now in terms of shear moment. Okay, special case of torsion ta. Aking critical natin. Okay. Lecture, moment, shear, tag, action. Pili pa sa iyo. Naka-loading form for second sem. Naka-open ang sequip, tag, ano isa lang semicolon.
Why ko na transpo, sir? Why ko na transpo?
Actually, from other schools, travel Manila, mag-open other specialization. Kay last time na may conference kami ng mga department heads with other schools. And we've talked sorry ako sa iba ng mga heads sa Aklan, sa CIT. CIT, di ba Cebu Institute of Technology. Actually, sila may pinakadamo ng engineering so far na balan. Kabla mo na sa Abilog, 3,000 plus.
Oh, lapit na natagli.
Civil alone.
Oh.
And ang ilan na offer nga sa certification is only consma abstract lang. Ang problem nila mag-open sa transpo is professors na capable to teach transportation engineering. Siyempre, limited lang yung experience if mag-transpo kami, so dapat nakalabay kami sa DOTR, Department of Transportation, yun, na naka-work mo dito. But unlike sa consma abstract yan, ng inyong field available workplace to have this experience is Stanford sa Bacolod. Okay, so inyong professors is capable to teach construction management kag structural engineering. But for transpo, kinanglan kabalo gid yan ang professor sa inyong transpo na specialization. The same struggle, would like mag-open transpo kung wala prof ang tudlo transpo. Salita, bed load. Kung gusto nyo pursue transpo, pwede ka apply sa DOTR. I think sa last 2017, damo sila hiring. Di ba damo sila projects? Yung sa inyo nga sa DOTR, they are the implementation side. So yung mga projects sila na, let's say, skyway, so monitor ka mo, construction, planning. Same sa DP, di ba each LGU, may agas sa planning division, may construction division. O, same na sa DOTR, may planning sila, may construction side na sila, at may design side. Sa itinerary, sa field trip, may
Matransport para kita mo tudlo.
Wala na lang. Basta may supit, no?
Bagyo.
Bagyo kang Enchanted Kingdom.
Ako strawberry.
Madamo na learnings.
Damo. Sir, tun anang moving load sa ride.
Lumos ka ron, ano?
May maskara na.
Nabot ka niya.
May maskara.
Lasirado mo ka ng mga dalan?
Hindi, may maskara sa sapatos. Highlight this week, no?
Sabado?
Ang Sabado.
Ay, sa Sunday?
Buta? Release Misal. Buwas. Gawin na tayo.
Boy, man ta klase? Hindi ma-NDM kami sa Sabado.
Okay, so this is BAEF. Okay, heads up ko lang hindi ka maka-load combination without your shear and moment diagram. Di ba from your theory 1, anong inyo ina-analyze aside sa reactions? Di ba you need to draw your shear and moment diagram for your frames. Okay, this kan inclined plane pa na siya, isang column pa na siya, you need to identify its shear and moment diagram. Dahil, hindi ka na-design for flexure if you don't have your internal moment. Okay, you can design for shear if you don't have your internal shear for each load pieces. Okay? Later on, talang i-discuss ang actual load, paano siya suma. Okay? Shear moment na nanay. So we have here our dead load. This is for dead. Having light load na ito.
Mga building. Torsion.
Sino makapakot? Anong tsura sa shear moment diagram for earthquake load? Di ba dead load is negative 72.79. For light, this is negative 38.77. Okay, this is your member EF. This is E. This is
38.35.
ang aton na wind load positive, no? Positive siya.
38.36 man.
Anong tsura si May?
77 sila kasi.
Live na sir.
Sir, 38.36 ko sir.
Ha?
38.36 ko sir.
3554.
Okay, call ang aton na wind load. Di ba may arata sa sa babaw? Tsaka. Mga di ba yung tsura sa load? Paano ng tsura sa aton na moment diagram? Mama na, alam. Di ba ang moment na dire is either positive or negative, no? So, pwede naman. Teka sure, no? Kung ilang moment dire, either positive or negative, kaya wala nakasuma sa moment about base of column F. So, let's assume for now, kung din kami sagad, okay, ang ato na moment at F is negative. So, let's consider ang itsura sa positive or negative? Hindi ko positive.
Positive ang industry sir?
Hindi, ang sa F, hindi ba this is 27.77. This is for the place of column A. Wala tang suma sa F ha. Masyong tama kasi pinjakon. Gasyong ka mga isang sala.
Eh.
Okay. This is wind load. Sa roof deck siyempre, ang inyong lower floor levels, then ang tsura sa inyong moment diagram. Then for your earthquake, sino makapakot anong tsura?
Kapadalong.
This is positive 21.59. Di ba earthquake wala sa uniform load? Anong tsura sa ato na moment diagram? Linear, di ba? Okay. So objective na for now, okay, i-determine na ito na required moment due to dead load, live load case 1, wind load case 1. This is case 1, live load 1, wind load 1, earthquake. Mas nag-out ang word ng seismic.
EQ na lang sir.
Seismic 1. Okay. Masuma tayo directly ang aton required moment at your call support E. Ang question, okay, sir, paano kami mag-design for our positive movement? Kasi diba, we need to provide a reinforcement sa midspan. Siyempre, ang aton yung dead load to live load, nakuha tayo immediately ang aton na maximum movement, di ba? Okay, this is the positive na maximum movement for live. Okay, this is the positive movement for dead. Paano sir mag-load combi in terms of wind load seismic load? Di ba ang mention ko sa aton na steel design na for our load combination dapat same location. Si ACI ga-allow, okay, approximately to load combi may certain zone na dire for positive moment, hindi siya kinahanglan na same location tanan. Eh syempre ang aton na distribution of moments dire hindi na siya same. If this is negative 72.79, dire hindi na siya negative 72.79. Syempre ang aton na end moment dire is distributed to other support no na adjacent sa aton na span EF. Okay, di ba si ACI ga-allow mag-load combi sa maximum moment at your midspan. Okay? So if ever mo yung load natin, okay, you can approximate also ano ang largest na negative moment acting at your midspan. So yung question, paano for earthquake loads? May ka moment sa midspan sa earthquake. We can consider 0 positive moment for earthquake loads. Amo na nga, pinaka-critical give, okay, na-design okay, for earthquake loads sa inyo nga support. Okay, kaya ang failure due to earthquake go for sa support not at your midspan. Ang mga critical ang reinforcing details na kinahanglan na himuon sa inyong na concrete at your supports due to earthquake loads. Kaya dali go for critical load, okay, caused by your earthquake. Okay, tatlo ka bilog ang inyong design for your lecture. Okay, left support, right support ng inyong midspan. Okay? There are cases ang inyong window hindi amo ni. Kasi di ba sa lower floors wala ka mo sa roof pressure. Okay, model ko lang liwat. Di ba this is the story shear due to wind load. Sa lower floor ninyo wala syempre isang uniform load sa inyong lower floor level. So ang inyong ding moment diagram more likely same sa inyong earthquake load. Okay? Na linear siya. So same scenario for your midspan, usually ka-govern nga load combi is only dead kag light load. Okay, kay 0 ang inyong moment sa midspan due to wind load kag earthquake load. Okay? That is for shear moment. Same na magladto sa inyong columns. So usually sa inyong columns, ganito mga idea. Okay, you need also to make your shear and moment diagram. Example lang yan. Okay, nangla na sa project project study at dapat may shear and moment diagram. Kaya hindi pwede nga mag-analyze sa structure without your shear and moment diagram. Ang question, sir, paano mag-plot ng shear and moment diagram? Explore your MS Excel.
Pwede ka
Good line mo,
Pwede
good
ka
line nga ikad nyo
Pwede ka
yung shear moment diagram. Kaya
Pwede ka
hindi
graph
kaliwat
Excel.
mo design. O alam mo gawing kaliwat, di ba? So dapat i-generate yung inyong shear and moment diagram from your Excel program.
May graph.
Column na column. Dead, live, wind, seismic. Okay. Anong usual for that load at live load? Ang aton ng mga values ng shear. Okay, usually for that load, okay, approximately 0 ang iya shear and moment diagram. But usual, ang iya value is gano'n lang. Either straight na siya, it is for that load. For live load, may unbalanced loading. Kamo kayo syempre, hindi same ang presence sa inyong live load for each span. Okay, meron kamo sa 50%, may 75% kamo. Pilang final, allow ni CERCDN430? Pilang ka load pieces?
100.
Tatlo, 100, 75, 50, 105. Live load, may gamon eh. So for wind load, paano yung wind load? Pwede siya gawin wind load, katrapesoidal. Okay, scenario lang yan. Siyempre, ang inyong shear diagram based na sa inyong structural analysis for each live load cases. For seismic big, gano'n mo na. Paano ka magsuma sa inyong moment? Dumdum ka mo sa inyong column, ang ato din na-consider, ibag-even ang moment usually. Okay? Hindi siya ka-moment usually, gina-refer na sa maximum moment. But for finals, hopefully na enough na meeting, we will discuss slender columns. Okay? Gaan mo concept, liwat. Okay, for our columns, there are instances mo. Okay? May ara ka sang bending, no, nga same ang ilang direction. Okay? This is single curvature na bending sa column. Example, live load ninyo, kung inyong na tsura sa moment, may positive kag negative. So, ang buwan niya, may sa moment na paamon Tapos may moment na mga pakatadali. Okay, and this is a double curvature. Ang question, sir, din ang hamon ang design. Okay, nga moment dali. Okay, so we will consider slenderness effects. Okay, we will discuss design per columns considering duwa ka effects sa moment. Okay, liwat ta kaya ang column fixed-ended sa top, fixed-ended sa bottom, hindi the same ang ila nga moment. Okay? Dumdum ka mo sa inyong design sa steel, na nagka-consider ka mo moment sa top, moment sa mid, at moment sa end. Nagami anong may M1, M2, M3. Di ba may mo ka mo sa steel? Yes. Okay. O same na lang dapat. We will discuss this by finals. But for now, let's focus sa beam. Okay? That is for our shear and moment diagram. So, yung question, paano ang actual? Dali na sa atin ang framing plan. Framing. So, this is your framing plan. Diba, we all know at each end spans ang aton na beams, di ba may shear ta? I-zoom ko na siya.
Mag-slide yun eh, sir.
Alam ta, along longitudinal, along longitudinal, may shear ka mo dali. May shear ka din. Okay, that is your end reaction. Okay, sa imo nga F, may shear ka man dali. Then, along sa inyo nga transverse, di ba may shear ka din? O, pag may shear ka dila ko, damo ka shear. Very shearful. Okay. So this is your column. Ano yung column ninyo? O, paano magsuma, sir, sa total axial load? Wala sa direct method, but rather, we need to draw our shear and moment diagram. Okay, if this is your column F, okay, this is along transverse, this is along transverse, this is along longitudinal. So, kung imo nga shear, matransfer diri. This is, let's say, for example, shear due to dead load. Okay, along the right side. Tapos may shear ka mo din due to dead load na araman sa left side. May shear ka mo diri na due to dead load. Okay, may shear ka mo diri due to okay. Let's say inyong load case is dead load only. So makuha ninyong inyong total axial load per column by summing all shears acting at your column. Ako lang for your interior column, dalang ko bilang inyong axial load kay apat ka beams ang iya nga gina-support. Okay? And this is the total axial load. May nakapos ang PD, okay, acting at your column F at each level. Okay, that is for your axial load. Same na. Repeat this step sa inyong live load. Repeat this step sa inyong earthquake load. Repeat this step sa inyong wind load para makuha ninyong total na axial load. Sir, paano sir ang bending? Okay, so since you have already have the idea, na ito na column is subject to bending. Okay, wala sang column na pure axial even this column is subjected into biaxial bending. Isa liwat, ang atom na shear is acting at the face of your column. Okay, di ba this is our axis? Di ba may axis ka mo? And your shear is acting at the face of your column. So miyarak ka mo sa eccentricity. Okay, ang inyong shear is not acting sa shear center. Uy, Steve. No. Shear center sa inyong column. So ang inyong reaction is may eccentricity. Same na din. May eccentricity din, may eccentricity, may eccentricity. Kaya mo na ang inyong design for your column is always either uniaxial or biaxial bending. Okay, more likely for your interior columns, ang inyong bending is small lang. Kasi syempre may bending ka at this side, may bending ka at this side. So ang inyong net bending about this axis is lumay lang. Okay, unlike unlike sa atong na mga corner columns, okay, aliw tawag na iterate ko sa inyong interior columns, ang inyong bending, pwede siya mag-cancel out. Okay, may end moment ka diri sa diri nga beam, may end moment sa diri nga piyak na beam, so ang imong final na end moment, pwede siya mag-amay. But for your column, for your columns nga sa corner, di ba may end moment ka diri, then you'll have also an end moment diri. So wala ka sang end moment at the other side na mag-counteract sa inyong bending. So ang inyong design for your corner columns, pwede siya ma-subject into biaxial bending. muna di kang masyak kapis mas dako ang reinforcement sa inyong mga corner compared sa middle. Siyempre, sa inyong middle, pwede makancel out ang moment. So, ang mag-govern is purely axial. Ang inyong corner is purely bending. And ang inyo naman yung edge columns, di ba may moment ka dere, may moment ka man dere, pwede sila makancel out, but may remaining ka moment at this direction. So, pwede siya maging uniaxial bending. So for short, pila ka bilog na columns ang inyo may design.
At
You'll
least
have your
3.
interior columns, okay, you'll have your edge columns, corner columns. But for your interior columns, okay, hindi lang na siya limited along sa interior. Wait,
Tila mo strong siya.
Bansit. Mariota, ang atong na structural analysis, we are assuming a critical frame. Okay? Whatever the reaction sa inyong transverse frame, same na dire. Okay? Whatever reaction dire, same na dire. Oh. Anong point ko dire? Let's say this is our critical frame. May shear ka dire. Let's say may shear ka nga, let's say this is 10. Dire may shear ka dire nga 12. Dire may shear ka nga, say 15. O may mula na. O, ano pang walang number? 8 naman na. 8. May shear ka dire nga 11 na. Tapos may shear ka din nga ano kulang? 9. Okay? O, that is along the longitudinal. But for your transverse, o, dali naman ta, let's consider a shear. Gawin sa lang. 20 plus naman. O, 21 diyan. 21. O, dire 20. Ano mas pili diyan? This is 18. O, dire 25. Ano pa kulang? 19. O, 17. Diba ta? Ang inyong transverse frame, same ang iyang effect. Dire. Okay? Kaya ang ating nubra is, we will represent all transverse frames, same ang ilang internal effects for each transverse frame due to this critical frame. Ang question is, same ay answer ang reaction sa interior columns? Hindi actually. Okay? O, let's consider column F. O, anong gaak na total axial load dire? Diba 20 plus 18 plus 12 plus 15. O, lain ang iyang axial load. O, for this column G, di ba wala niya shear dire? O, 8 plus 11, okay? Same na transverse frame, plus 20 plus 18. So, lain mo di iya nga axial load. O, dali na in man. O, in total, pila ka unique columns?
1, 2.
Pila?
Tanan.
Damo, no? O, so, for short, tanan na columns, i-investigate ninyo. Kaya ko yan, investigate ninyo para palaan nyo pila ang may common na number of bars. Let's say, you will design all columns per floor level, tapos mapili ka mo sang size ng bar na 20 mm. O, let's say, ang common nyo being a design is miyaga sang 20, okay, miyaga 18 bars, miyaga 14 bars, at miyaga sang 10 bars. Ang uning common na number of bars sa design sa inyong columns at all floor levels. Okay? And then, direct ako mo-decide na, okay sir, apat ng gali for short ang among na total design. Kasi syempre, ang inyong number of bars, hindi mo siya relevant sa inyong... Okay? Lota, hindi na mag-strong pansit. Lota, even though laina yung actual load for each column, okay, for each grid, di ba laina yung ka-design? Kaya ang atong nga design is, gilayan if bilang number of bars. Oh, so, if ang inyong design, na-discover mo, ng common na design is 20, 18, 14, kag 10, pwede ka ka-decide ng imong final design o sir, C1, C2, C3, C4. O, take it out. Okay? Dili ka mo-decide kung pila ka unique design of columns. Okay, you need to investigate tanan, each floor.
Di pwede pariyosan, sir.
C1 lang tanan. Siyempre, lain na yung actual load yan. Lain ni, lain mo dire, lain dire. Okay? So that is for your column. Simple na, di ba? Okay. iya para makahimo ng sa inyong chapter 2, di ba deadline next week? Okay,
Spoiler alert.
Okay na? May idea na ano? Ano brown niyo?
Idea na.
Overtake. Dalitan. Man-load combatant. So let's consider our all live load cases. So for our dead load, isa lang syempre, no? So we'll have load combination sa iya, moment at E due to dead load. Then for our live load, we'll have 4 cases. Live load 1, sorry lang no? Ang ina ng Del. Live load 2, live load 3. So mayroon ka mo sa moment at E due to live load 1, moment at E due to live load 2, then moment at E due to live load 3. Next, wind load. Ang pinaka-due tayo. Pinaka-wind load cases gani. Wind load case 1, wind load case 2, wind load case 3, wind load case 4, 5, 6, 7, 8 lang kabilog ang wind load case natin for each frame. Okay? And syempre, at our moment, this is moment at E due to wind load case 1, moment at E due to wind load case 2, moment at E, Lutay lang. Kaya lang yan 1 week.
Ang isa ka case.
Wind load, case 8. Okay, atong isuma isa lang case 1 lang.
1 week na. Case 1 ng 1 week na.
Earthquake load, case 1. Earthquake load, case 2. Siyempre, ang reverse effect, we'll consider that. Moment at E due to earthquake load 1. Moment at E due to earthquake load 2. So, amo ni dapat ang inyong total end moments at your face of column E at the roof deck level for your beam EF. Okay? Ang insuma apat lang. Okay, out of ka muna isip.
So, ito lang nasa.
48 ko load.
Service components
48
lang
ko
na.
combination.
Ang atong objective is to identify ang atong na required movement. O dirita sa atong na load combination.
Grabe naman na sir.
Section 405.
0.3.1.
Okay, so we'll have equations 1, 2, 3, 4, 5, 6, 7. Solving for required moment at E. Dinata. First equation.
1.1.
That is 1.4 moment at E due to dead load. Next. Okay, this is equation 1, no? Equation 2 ta. So for equation 2, we have 3 elements, no? Dead load, live load, then ano yung ang LR or R? Ang LR ninyo is your roof live load, ang R ninyo is rain load. Okay, so you can put on your scope and limitation ang inyong load considerations only live load lang, wala kang rain load. Okay, if na-consider pa rin isang roof live load, pwede mo na. Okay, but for our load cases, only dead lang
Panding load, yawan.
live load. Next,
Wala,
MU, E.
Why do you click
Anong
H
first?
na?
1.2 dead.
H na load.
Moment at E due to dead load
Earthquake
plus 1.6 moment at E live load case 1. Ano pa again? Next, 1.2 moment at E dead plus 1.6 moment at E live load case 2. Please ulit, no? 1.6 moment at E live load case 3.
Hasta lang tracer.
1.6 moment
Hasta lang
at
tracer.
E, live load case 4.
Hasta lang tracer.
Ay, sorry, live load case 3 na nanalo sa 4 cases. So, equation 2 pa lang. O, next. O, 3. Akin na. Akin ang sadya. Wind load lang. MUE. That is 1.2.
Dead.
Moment at E due to that load plus, di ba may or siya? Okay, may 1 live lag, 1/2 na wind load. So we all know ang 1 live, hindi na siya mag-govern. Okay, di ba or siya? So dapat 1.2 plus 1 live. So yun, 1.2 plus 1/2 wind. Since we have already 1.2 dead plus 1.6 live, we all know na hindi mag-govern ang 1 live. So instead, gamiton na ang 1/2 na wind load. So 0.5 moment at E due to wind load 1 plus 1/2 moment at E due to wind load 2 plus plus 1/2 moment at E wind load case 2. Planic equation, this is 8 equation. Ari 3, Ari 1. 8, that is 4, equation 3. Ano pa lang inyo nga i-load combi para makuha ang ato ng required moment at E. Sa 4.
1.2 dead plus 1 live plus...
That is...
1.2, 1 with 1 live.
Akin na. Akin na ginaulat. 1.2 moment at E due to dead load plus una ako tang live load 1 live, 1 wind. Na ako si live 1.0 moment at E may due to live load case 1 plus 1.0 moment at E due to wind load case 1. Plano ka bilog.
20
Plus
24.
wind load case 8. 4 moment na live load case 1. Plano ka bilog.
24 tanan.
This is 8. May isa pa. 1.2 moment at E due to that load plus 1.0 moment at E due to live load case 2. Same with that one. Moment E, live load, wind load case 1. Wind load case 8 naman na din. Pila pa?
8 pa sir.
Last pa. Last na lang, last na. May 3 naka-live load case, no? Mapa-open special class sa CERCDN.
Flexible pa naman yun.
I-overload ka. Paligid mga capitalization, CERCDN, C-Quip, C-Cost, C-Cosh, tag, CERCDN.
Para makalabas na.
Sir, W8 sir.
Ay, sorry na bilog.
Oo. Art up pa din.
Equation 4 pa lang. Kailan nakabilog? 4, 12, plus 24 is 36.
Meron pa to sir ano? 1.2D plus 1E plus 1L.
Sa E pa lang na. Sa E pa lang. Wala kang bilogan eh. Sa isa ka bin, tatlo di ba? Left moment, left span. Okay. Mid span tab, right hand movement
Sir?
for each beam. Ang question, pila ka beam sa isa ka frame.
Maamo niya daw.
Tapos, pila ka bilog na frame, di ba 2 ka bilog?
Ano
Doon tayo
lang?
Kaya ako na hindi ko masyak ang ilang ka per study, ang mga kadamol. Volume 1 pa lang, may volume 2 tab, volume 3. Cloud chasing lang. Next. Okay, equation 5.
1.2 dead.
Okay, ano yung equation 5?
Sir, not adequate lang kami, sir.
Ha? Tignan mo adequate.
1.2 dead.
1.2.
Dead, plus 1 earth, plus 1 live.
Oh, naman.
Yan ang anom, no?
Oo, sir.
Ikaw mo kabala ka, kaya ang inyo lang din na technique is Excel. O, drag lang, di ba? Pag drag mo, kita na nagwa, ang equals number ref. Uga, pag dalag uga po ka na naman nagwa.
Ha? Galing sa ganun, ha? Ano na ni?
Then that is earthquake, no? 1.0. Pila sa equation 5 this is
6.
6.
Di na taguro, sir, mag last 2 ng formula, no? Kay mas gamay man nila nga coefficient sa babaw.
0.9 dead, no? Hindi.
Wala.
This is 1.2. Ang wind load is 1/2. So, base mas takot siya. Consider ka. Equation 6.
Ayok sa tanong. Duwa ba? Tanogod ba na?
0.9.
Napila na kabantay ka.
Hindi. For example, isa lang ka load case. Kaya kami ako emphasize after this.
2,200 pages. Sila ni Neil Andrew Tan, 1,200.
Kala ba na yun? Sa Excel ba?
Ilan tao ganin laban yun, no? Laban MDM, Excel. Mga screenshots ng Excel, no?
Ay, sorry.
Okay lang, sir. Butangan na lang, Win.
7. Equation 7.
Sure.
1.0 win.
Pipit to.
Siya na.
Oh.
Nakatry na ka mo load com base sa inyo, basta C-com. Wala pa.
Okay pa, sir.
Basta, sige siya yung C-com. Kaya sa C-com, yan ninyo, basta, ang inyong input is, ano lang, anong load cases, siya na ma-identify pila kabilog na live load, pila kabilog na earthquake, pila kabilog na wind load. Yan inyong input na wala nito. May mamatay. Ka-force.
Karak din mo.
W8 yapon, sir.
Sa cell.
Wind load, pilang total ng load combination?
1, 2, 3, 4, 5, 6. 52, sir.
Total of 52 load combination cases. O sa isa lang ka, end reaction movement lang, di ba? May shear pa kag ano pa? Action, no? Sa column. Sir, question, sir.
Not adequate.
Saan po kami, sir, na-design for torsion?
Checking the...
Depende na sa inyong framing plan. So if ever, may kami sa spandrel beams, may anong beses sa mga spandrel beams, may ako sa edge girder, tapos may katungtong na intermediate beam. Okay, so you need to investigate your exterior girder for torsion. Okay, di ba for torsion, dapat investigate ninyo if ever may exterior girder ka mo. Ano siya? Column, girder, column. Problema, sir, lagka among column. O, let's say 6x6.
Uy! Do specific example lang.
6x6 ni.
Specific example.
Problema, sir, naman sa kalapan, mabutang kami intermediate beam.
Hindi eh.
Duwa ka bilog ah.
Para ma one way.
Isa lang. Isa ko no. Theoretically, isa ko no. Wait na lang ba ako magsinugalin? Isa lang. Take note ha, ini nga girder, this is spandrel beam. Then ang inyong end reaction due to this intermediate beam, i-transfer nyo dito, so mayroon ka mo sa torsional effect. So you must investigate your exterior girder for torsion. O check that light ilang inyong factor TU, then check for your threshold torsion. Kung needed, mag-decide for torsion. O amo ni ang peril if mag-utang ka mo sa intermediate beam. Kaya ano rason? Para sa mag one way amon na slab.
Pamilya na.
Siyempre mo one way, di ba? Kung 6 meters din,
Mga
o 3 meters, it is 6 meters, o one way slab.
Uy.
O kung lima ka, may spandrel beam ka. O ma-check isang torsional effects. Ano option ninyo? Nakapso na lang sila. Two-way slab kami yan. We will discuss two-way slab sa Tuesday.
Dugang kulong. Dugang kulong.
Liwat na, wala na quiz next week. Medium round na is nakusot ang topics up to this ano footing subject to landing. Okay, para wala na utang sa inyo sa midterms. O bakit never damo wala klase sa finals, kompleto ninyo ma-design no footing, two-way slab. Mag-quiz na after sa exam.
Field trip.
May mantakan ka mo.
Mag-field trip, sir?
After exam, di ba sir, may ano? UX?
Online.
Kung tama sa anong schedule of activities sa UWIC, kumitar po na. Day 1, quiz, CERCD.
Pay-per-view
So let's
tayo.
do our load combination. Okay, for this problem, ang load combine na
Grabe nga sideshow ba?
Okay, so for our first equation, it is 1.4. Okay, moment at dead T, this is negative 72.7935. Ilan eh? Correct, yes. Lahat up? Negative
101.9109.
101.09
9109.
Next equation, MU E, that is 1.2 dead plus 1.69. Ilan ni?
Negative 148.
Negative
148.
148. Yung mo?
Hotdog.
1.2, 1.6. Negative 148.7208.
172.08
08.
kilometers. Third equation. Okay, so for our third, that is 1.2 dead plus 1 light plus 1 wind.
Oh?
That is
1.
Sir?
1.5.
One? Hindi sir ano, one half win.
equation 3, no? 1 half wind is sorry. Plus 1 half, ang wind load is positive.
Din na.
Ilan ni siya? Negative
73. 4657.
Next, MU E for our fourth equation. Okay, may harap na sa live kag-win. 1.2. Okay, this is moment at E. This is negative 7. Tapos,
Win,
1 win. Plus live, no? Live.
1 live.
Ilan eh? 9. fifth equation.
Earthquake.
1.2 negative 72.79
E1.
plus ME1. Okay na. May notice ka mo sa load combination. Okay, anong usual ng pag-assign?
1.2.
Combination pag-assign. Wait, takas. Usually ba first is dead load only. Second, dead and live. Third is dead or either dead plus wind. Okay, ang fourth is dead plus wind plus live. So, let's say gabagyo, ang occupants, tapos may dead load. Okay. Equation 6. 6 no? Equation 5. May dead load, okay, nalinog, tapos may occupants. Anong last two?
Dead kagwin.
Dead load na lang kag-wind load.
Bakante.
Nakatay occupant. Okay, nakatakas na occupant, no? Okay, wala na sa occupants, tapos natigil na bagyo. Hello, ay mo na, dapat tayo ng live load, no? Naging mo na dead load. Last is, may dead load ka mo, wala occupant, tapos nag-linog. Okay? Wala sang case dali na naglinog samtang gabagyo. Yung nakamalas na goma sa picture, di ba? May wind load na, may earthquake load pa. Okay, question ko. Okay, for our equation 5,
Wag ka malo kasi madungan sila.
kaya yan, equation 5 is it directly ang muling value. Okay, ang gamiton ng earthquake. Actually, hindi pa. May tugang na ako. Section 402. Sorry, 402. Section 208. Okay, so these are your earthquake loads and modeling requirements. Okay, kinanglan 5-4. Tapos, at least of 18 years of age. Okay, for our earthquake loads, ang ETA, okay, di ba doon sa load combine, ari nga E lang. Di ba 1.2 dead plus 1E. Okay, gamiton ta, is ari. So, ETA is composed of two components. Okay, may horizontal components na components. Horizontal component na EH and vertical component na EV. Okay, and this row, this is your redundancy factor. Okay, ang EH is the horizontal component. EH, okay, this is the earthquake load due to the base shear B. So for short, ang ato ni siya na moment at E due to earthquake, this is only due to base shear. Okay, may vertical component pata before natin siya ma-load combination. Okay? So EH daw that is the effect due to base shear only. Then ang ato nga EB, okay, this is the vertical effect, no? Resulting from the vertical component of the earthquake ground motion and is equal to an addition of 0.5 CAID. Okay, ano ni siya na D? Okay, that is the internal reaction due to that load. May it be ang moment na gina-analyze ninyo for E, or inyong shear, or inyong axial load. Dalitan. As per code, our earthquake load is equal to rho EH plus EB. Okay? Ang EH is the internal reaction due to base shear pa lang. Pero ini siya nga movement at E due to earthquake, this is only for base shear. Okay, dugangan pa nato ng atong effect for earthquake loads na this is your EB. Okay, so we can write this as moment at E due to earthquake is equal to rho. Okay? Moment at E, okay, this is H plus moment at E, vertical. So EH, earthquake horizontal, and this is earthquake na vertical. Okay, wherein ang aton nga moment at E, okay, for earthquake load sa liwatan, ang E ni siya, this is the location sa inyong mga column. Ang ini nga E, this is due to earthquake na horizontal, and that is equal to positive 21.5925 kilonewton. Okay. Due to base shear pala na. Then ang aton nga vertical component, a moment at E, Okay, due to earthquake nga vertical component that is equal to okay, 0.5 CAID. Okay, base lang inyo ang interpretation, i-add nyo sa moment dead. Okay, ang iyan ang interpretation nga in addition to dead load effect B is may existing na dead load, may dugang pala nga 0.5 CAID. Okay, so for short, this is 0.5 CAI moment at E due to dead load. Okay, gaka-amplify ang aton na earthquake, no, na internal reactions due to this vertical component of your dead load. So 0.5, ilang CA gani earlier?
0.44.
0.44. Ang I is 1. Moment at E due to dead load is negative 72.7935. Ilang vertical component?
Negative 16.0146.
46. Sir, okay na sir. Kalaina yung amon na moment due to base shear kang iya nga vertical component. For this load case sa earthquake load. Eh syempre, di ba, ini siya nga load case for earthquake load is ang aton na direction for sway is going to the right. But if ever mag-reverse ang aton nga direction sa earthquake, ang aton nga moment is negative ni. So therefore, ma-amplify ang final value nato for our earthquake load. Yung lang is mas critical siya if ever mag-reverse. Okay? Last, ang aton nga redundancy factor. So what do we mean by redundancy?
Switch ulit.
So it's ulit. Okay, so we won't use this equation because wala kasang properties ang aton ng mga columns. But for sure, ang aton redundancy factor or reliability factor, the way ko na mag-fail ang aton na framing each floor due to earthquake, let's say, may series of columns na mo. Okay? The ways na mag-resist, if one column ma-fail due to earthquake, the rest is ma-fail na siya. Okay, mas dako ang redundancy factor niya. If one column will fail, tapos tanan, may iba nga, no, framing system, if one column will fail, the other two will still remain ma-resist na yung earthquake loads. Okay? And this can be solved using your story shear. Okay, yan siya ng RMAX. O, baka at least may idea ka mo. Okay, di ba may mention ko earlier? May mga story shear ratio.
Maximum.
So, your R is the element story shear ratio. So when you say story shear ratio, okay, that is the ratio sa inyong total story shear, total story shear force divided by your each column na resist rin. Okay? Wala nang earthquake loads, ano? But don't worry, we don't need to solve for your rho, but we can use the conservative value. Okay, so rho shall not be taken less than 1.0 and need not be greater than 1.5. But if ever ang aton nga framing system is an SMRF frame, SMRF na ganito, tapos may frame pa, okay, except when used in dual system, so inyong framing is SMRF na wala shear wall, okay, dapat ang rota shall not exceed 1.25. And we will use the conservative value nga 1.25 for our rho nga SMRF. Okay, and this framing is SMRF, so we will use rho nga 1.25. Okay, so the final value natin for our moment at E due to earthquake load, okay, that is 1.25 sa base shear natin, may effect that is positive 21.5925, okay, minus the plus negative 16.0146. Pila na yun?
$10.9794.
Positive.
Positive.
10.9794.
9794.
Okay. And ang gamiton na for load combination, okay? Not this one. Okay, this is the horizontal component na load pa lang due to base shear. Okay, we need to add the vertical component natin as defined by 0.5 CAID. Okay, kaliwat ang initial na D, okay, that is your internal reactions. Okay, na siya na D. So may it be moment due to dead, shear due to dead, or action load due to dead load. Okay, Also for our fifth equation, ano siya? Okay, for our earthquake, that is plus 1.0 10.9794. Then, live load mo. Plus 1.0 negative 38.3554. Ilan eh? Negative yes, correct. Ilan to?
Negative 114.
114.7282.
0.7282.
Okay, equation 7. Equation 6 is 0.1 negative 72.7935 plus 1 with ilan siya?
Negative 37.
Negative 37.74.
741. Ilan eh? Last.
1794.
Negative
Negative 54.5348.
5, 3, 4. Ano ang largest or nag-burn?
Negative.
Equation
Ang
2.
1.2 dead Japan no kag 1.6 live. Ari ang maximum. Okay, this is for the case no. Nga nato nga earthquake load is case 1. Okay, na nato nga live wind load is case 1 also. Okay, may tendency niya na mag-burn is ang ato nga earthquake loads. Okay, kinakabuan diri ang ato nga earthquake is positive. Okay? O may mga chances kasi ang ato nga dead load is negative. And if ever mag-reverse ang ato nga earthquake, pwede ni siya mag-negative. Okay? Ma-add up ni. O pwede mag-burn or ari ang earth. Okay? Therefore, ang final na required moment at E, okay, that is negative 148.7208 kilonewton. Proceed na kamo sa decide. Okay?
6 hours nga lesson para sa isa ka answer.
Para sa isa lang ka moment. No? Ano masakos na structural analysis? Approximate, portal,
Wala.
ano, MDM, di ba?
Pansman.
Okay na? Okay, na-consider tayo sa case for live load, case sa case for wind load, at sa case for earthquake. Tabuan lang ka muna nag-burn. If ever, tanang na cases, may possibility na no, ang mag-burn is earthquake. Naku, walang chances na earthquake ang mag-burn. Ano pinakapos? I-locate nyo yung building na outside sa zone 4. At the end.
Palawan.
Away na tayo?
Ay na lang alam mo, sir.
Alis yun na, kapoy na ako. Maganda na.
Kapoy si World Sir.
Ako na, gano'n niya, gano'n. So next week na lang yan. So we'll have 2 topics next week.